So this was the house rules I covered just now. I mean, it's just a brief one. Okay, we'll get started with the questions first, right? Like I said, we're going to just dive right into it because we do need to spend a bit more time going through these questions, yeah? Okay, first question. Cassie wanted to open the metal lid of a glass jar. She placed the metal lid of the jar in a basin of water as shown. After some time, she still could not open the metal lid of the jar. So which of the following should she do? Okay, I think this is a concept you might or might not have learned about heat. But if you have attended our lectures, right, our lessons online, I think you will roughly have an idea. This is actually testing you on expansion and contraction. Okay, so expansion and contraction, we'll then have to ask ourselves, where is the hotter region? Okay, but in this case, let's see. Okay, so over here is a metal lid. Metal lid versus glass jar. Okay, so the other concept that encompasses this question would then be whether is it a good or poor conductor of heat. Okay, so here are some concepts, underlying concepts, which you need to apply to answer this question. Hence, okay, what do you think she should be doing? Let's look at option A. Yeah? Remove some water from the basin. Does removing water from the basin help? Basically, you're just putting less water. No. Okay, using a bigger basin. So instead of a small one, we use a bigger basin. Yes? Yes or no? No, right? Okay. Do we place the entire jar submerged in the water? Do you think it will help? Basically, we are putting the entire jar means if it gains heat means both glass jar and metal lid will gain heat. So this is not correct as well, right? So the best option would be D, because if you were to use hot water here, what will happen is that the metal cap, the metal lid will expand because it will gain heat, it will expand. Okay, so it will gain heat and expand. So that's how you explain your answer in open-ended questions as well. It will gain heat and expand. And when it gains heat and expand, that's when you can easily remove the metal lid of the glass jar. Okay, so this one, the answer is D. Any questions? Okay, great. Let's move on to the second question. Elaine, notice that there are gaps in the train tracks as shown. The purpose of the gaps is to purpose of the gaps. Yes. Read it.
Allow for expansion of the tracks on a hot day.
Well done. May I just clarify, is Ryder really your name? Ryder Gui, is it? Is that how I pronounce it? Yes? Okay, nice. Interesting. Very interesting name. Yes, correct. Because if you have space, if you do not allow it space in hot days, it will just buckle up, right? It will expand too much. And if it buckles up, it will then cause danger to the train, to the passengers on the train going on the track. Okay, so yes, it is to allow for expansion, definitely not ventilation. Okay, ventilation means you want more air, right? That's not correct. Decrease the amount of contact, that's incorrect as well. Why do we want to decrease the contact between the tracks and the train, right? It's going to be dangerous as well. Okay, and also it's not because we want to reduce the amount of materials. Okay, so the best and the most logical answer would be B. Are we good? Yeah? Okay, let's move on. Money, are you okay? Yes? All right. Okay, now this question, water can change from one state to another through different processes, okay? This one, you will learn even more in primary 5 under water and its change in state. Okay, but I think at your level, at primary 4 level, you are also supposed to know about how these processes involve heat gain and heat loss. Okay, so for solid, for example, your ice cube. For your ice cube, okay, to become liquid and versus gas, right? For your ice cube to become liquid, do you think it needs to gain heat or needs to lose heat? For the ice cube to melt, to become liquid, is it heat gain or heat loss? Anyone? Yes, Ryder.
Heat gain. I mean,
Very
heat
good.
loss. Yeah, heat
Hey,
gain.
heat gain. Okay, so heat gain, because from solid to liquid, right, you need to gain heat. And when it gains heat, that's when it starts to melt, because the temperature increases, the amount of heat energy increases. That's when it can melt. So this is a heat gain process. A are heat gain processes. Okay, then next thing is, for example, you want evaporation from liquid to gas. That means like from a puddle of water, then it becomes water vapor in the surrounding. So liquid to gas, okay, this process is called evaporation, right? This is melting. Sometimes liquid to gas can be this process called boiling as well. When you're boiling a kettle of water, right? When you're boiling, it turns from liquid to gas. So this process B is also a heat gain process. Okay, it needs to gain heat so that it can evaporate or boil. When you're boiling something, you put the pot of water on the stove, right? So it needs to gain heat for it to become a gas. And of course, on the other hand, we have our gas to liquid and liquid to solid. Now, when gas turns to liquid, the process is called condensation. When liquid to solid, the process is called freezing. Okay, so there it is, C and D. Answer is C. Are we good? Yeah? Okay. So next one, Regina placed equal amounts of ice cubes into 4 cups, P, Q, R, and S of the same size. The cups were made of different materials. The time taken for the ice cubes in each cup to melt completely is shown below. Which cup should Regina use to serve hot tea so that the tea would cool down the slowest? Now, if you want something to cool down the slowest, or we want it to melt the slowest. Okay. Right, we want it to cool down the slowest means we want to keep it warm, right? When we want to when we want to cool down the slowest means we want to keep it warm. We don't want something to turn cool so fast. And when we want to something to melt the slowest, like for example, an ice cream, you do not want it to melt the slowest, right? Sorry, you do not want it to melt so quickly. So you want it to melt the slowest. Therefore, basically, you are trying to keep it cold. Okay. Now, the thing is, whether or not you want to keep something warm or keep something cold, right? The thing, okay, the conductor that you want to use is always, let me use another color. Okay, it's always poor conductors of heat. Okay, why is it poor conductors of heat? I'll give you an example. Okay, for example, ice cream. You do not want the ice cream to gain heat so quickly. So you want to put ice cream in something that is poor conductor. So the heat is not conducted to the ice cream so fast. Okay. Then, for example, you have like a hot chicken soup, right? Your mom made you some hot chicken soup and she usually puts it in like a thermal flask. That's because we do not want the heat in the chicken soup to be lost so quickly. So whether or not you want to keep something warm or keep something cold, you will want it to be a poor conductor of heat. Okay, right? All right. So now let's take a look at the 4 cups. Which one took the longest time for the ice cube to melt? Which one took the longest time for the ice cube to melt? Yes, Money?
Is it cup R?
Cup R, so what does it tell us about cup R? Is it a good conductor or poor conductor? It melts the slowest, right? The time, yes, very good. The time taken for the ice cubes to melt completely is the longest, which means R is the poorest conductor of heat. We have to use superlative poorest because we're comparing more than 2, okay? So it's the poorest conductor. Now, of course, the best conductor has to be P, okay? Because, right, we use superlatives again, best conductor of heat. The reason why we use R is because, like I said, we want to cool down the tea slowest, right? So we do not want to use a good conductor of heat. We'll use the poorest conductor of heat. So the answer is D. Okay, any questions with this? Good. All right. Okay, next one is quite simple. Which one of the following is not? Now, whenever you see the word not, put a cross first. Okay? Is the sun a source of heat? Yes. Is the lighted bulb a source of heat? Is the cotton shirt a source of heat? Is the candle flame a source of heat? Yes? Okay, I can see the tick and Money's screen. Yeah, a cotton shirt is a poor conductor considering, it is quite a poor conductor of heat, but it's not a source. A source of heat means it will give off heat on its own. Okay, so we are looking for crosses. Answer is C. Okay, not too difficult, right? This one is quite straightforward, yeah? Okay, now next question. Ronald places a metal rod in a cup of hot water. Okay, the metal rod becomes hotter after a while. What explains this? Now ask yourself. Yes, Money.
I just wanted to give the answer.
Okay. What is it?
A.
A, is it? Okay, let's check your answer, yeah? Now, for such questions, always ask yourself, where is the hotter region? Because the concept is heat always, okay, always travels from a hotter region or object to a colder region or object. Okay, so heat always travels from a hotter region to a colder region. Yeah, so always ask yourself for such question, who gain heat from who? Definitely the one which is the colder region gains heat from the hotter region. Who lose heat to who? It has to be the hotter region lose heat to the colder region. Okay, so in this case, the hotter region, of course, is your oops, I wanted to use orange to show that it's really hot. Okay, your cup of hot water is the hotter region. The colder region is your metal rod, right? So the rod gains heat